Okay, so this is the week one material lecture for data mining, and I'm pulling up the slides now. Okay, welcome. So this is basically an overview of what data mining is and some basics. Our first learning objective is to define what data mining is. It's kind of hard to define it in one precise way, so there's really three ways that you can define what data mining is. The first is as a process. This is the one that I like the most, and data mining is best thought of as looking for patterns in a data set. So you have a bunch of data, and what you're doing is you're looking for some type of pattern in the data. If it's consumer data, maybe some type of buying pattern. If it's medical data, maybe a pattern of diseases and the symptoms associated with them. But data mining is all about discovering patterns in data, and that's really the most helpful way to think about it. And it's not really like basic statistics in the sense that you're necessarily just doing like means and medians modes and doing descriptive stats. A lot of data is not numeric, and so you're basically looking at a data set and you're trying to figure out if there's some helpful patterns in there. And that's really what data mining is all about. It's analogous to mining for gold, which is why it's called mining. And it is not really as mathematical or computery as most people would put it. So really to set the stage for this course, data mining is about finding patterns in data sets. It can also be thought of though as an interdisciplinary field, as can data analytics in general, which is that there are some techniques from stats, not really so much from math. I mean, there's not really that much high-level math in data analytics, which I think a lot of people find a little surprising. Some techniques from computer science and data management, some techniques from what could be considered machine learning, artificial intelligence, and typically data mining is actually being applied to some type of field of application. Business and healthcare historically have been giant users of data, but now all sorts of other fields are getting involved as well, and data is everywhere. So you can think of it as an interdisciplinary field or as a process of discovering patterns, or also just simply as a subfield of data analytics because data analytics includes data visualization, wrangling, other subfields, and data mining can very much be considered a subset of data analytics in general. Okay. The next thing to do is to recognize the history of data mining. It is not all new stuff. A lot of data mining has been going on for sort of quite a while, not really in the context that we think of it now. But admittingly, I put this together by kind of like just looking stuff up on the web and stuff. And I'm not really much of a historian, even about data mining. So this is just some highlights that I found on the history of data mining to sort of put everything into a perspective. Okay. Data mining sort of starts in the 1960s. Really, before then, there really was no such thing as data mining. Everything was just in an office on paper. There really wasn't anything computerized. And then the 70s, things sort of started up. The 80s are when data mining sort of officially became more defined. The 90s, the 2000s, the 2010s, and the 2020s. So let's highlight sort of a few events that occurred that are notable during these decades. Okay. In the 1960s, I was not even alive then, this long ago, there was statistics and mathematics. There were not yet a wide use of computers, but the idea of automating data analytics became something that became possible because there were sort of really, really elementary, sort of big machine kind of things that I wouldn't really call computers. This guy, Fetterman, he is credited with coining the term data mining back in the 1960s and referring to the process of extracting insights from data. So he is the man credited with the terminology data mining. Okay. In the 1970s, which is when I came into existence as well, computers came into existence. Okay. So researchers started to use computers to analyze data, which is a really, really big step for mankind, right? Because before then you had to analyze data on paper, which wasn't really very efficient. So this guy, Quinlan, he's pretty famous for, we will actually see in this class some decision trees. So in the late 1970s, the very tail end, this man by the name of Quinlan developed this algorithm for what's called a decision tree that you'll see that's used in data mining. So that was kind of notable. In the 1980s, this is when computers suddenly started springing up all over the place. Desktop ones, not so much the internet networked ones. There was a guy in the late 80s named Gregory, um, I can't say this for the life of me, Piatesky Shapiro. He is coined with the term KDD, Knowledge Discovery in Databases, which is about finding patterns and relations in data. KDD was basically what data mining was kind of called then, even though this guy had developed the term data mining in the 60s. So this guy Shapiro, or I can't say that, sorry. He is credited with this KDD. KDD basically means data mining, but it's called knowledge discovery in databases. Um, Business use. So the 1990s, now all of a sudden, the 70s, you sort of have primitive computers. The 80s, you start having your like Apple IIs and your like Macintosh and your kind of like basic desktop computers. They weren't very powerful, but by the end of the 80s, pretty much everybody, like computers were all over the place by then. The internet, not so much, but people did have the desktop computers, and computers by the 1990s, computers were kind of everywhere. And the 1990s, of course, are when the internet started blowing up too. Um, but business use. Now, when businesses start using things, money gets involved, and if money gets involved, people see the value of doing things, and value and profit are what America is all about as a capitalist society. So therefore, all of a sudden, things like data mining become much more important. In 91, IBM introduced intelligent miner data mining software. Now, IBM also does SPSS, and I believe there's a connection between this and SPSS. We use SPSS in the Stats 2 course. SPSS is primarily used academically still. It's not, I don't really teach it as part of data analytics because it really is still much more in the social science academic research world and not so much in a data analytics job. But we do use it in Stats 2, and it is run by IBM as well. And so that software, the Stats 2, has been around for nearly 50 years now. And their data mining software, which I believe now is sort of part of SPSS. SPSS is like cartridges. So you can get like a base version of SPSS, and then you can get like these add-ons. I believe this intelligent miner is still incorporated into like some portion of SPSS advanced functionality. But anyways, so the thing about this is now specific data mining software. So that was a little over 30 years ago that they had data mining software. In 1995, there was an international conference on this knowledge discovery and data, aka data mining. And so that essentially was a monumental thing. This is 28 years ago, where you now have a very monumental event where you have an international big conference on data mining. And so now data mining is kind of taken off as like something really important. Okay. When business starts using things, then people need to know about it. The late 90s, early 2000s, sort of, first we have the wave of computers going on people's desks, then we have people learning like Office software and Excel and stuff. Now we sort of have the beginnings of the internet, and then businesses start recognizing how valuable gaining insights from data, particularly in something like sales, where you're looking for customer behavior and you're trying to target what people will buy, you're trying to figure out what to sell to people, among other applications. But all of a sudden, businesses are like, hey, this idea of using data is really a good idea. So, data mining techniques are used to start identifying patterns in customer behavior, marketing trends, and other areas of business, which still today, I do want to start a business analytics specific part of this program as well. But business use of data, I don't think that can be underestimated, the importance of that. Okay. So that was the 70s, 80s, and 90s, and then around 2000, which is when the internet literally exploded right around 2000. That was really sort of like the boom, right? And so around 2000, there was also an open source data mining, which meant it was free, which is what R is. And then when something's free, people will use it more because they don't have to pay. So two things occurred in the early 2000s, one of which this Weka, which admittingly I have not used this. I probably should play with it someday, but I think it's still around. I'm not sure. And then also in 2003, 20 years ago, a book came out, which was one of the first sort of data mining books, and became a popular textbook for data mining courses, which of course meant that data mining courses started being offered. And therefore, things started to take off a little bit then. Okay. Also in the 2000s, they started tossing the term big data around. Now, big data doesn't really mean anything specific. It just means that all of a sudden there's a lot of data. And so, roughly 20 years ago, when the internet started exploded, so did all of a sudden the collection of data that we're obviously still figuring out what to do with. And now we're at the era of analyzing the data and working with it and doing things with it, because there's a lot of work to be done. Also, another thing that was important, I don't know that much about like platforms and back end data stuff, but something about this Apache Hadoop, apparently it just made it like a lot easier to store like big data sets and work with them. So it was kind of a monumental technical occurrence. Okay. In the 2000s, Google introduced something called MapReduce. I don't know if that somehow became Google Maps or what the connection is here. And then in 2005, again, yet there's another international conference on data mining, which is sort of like the one on KDD that was like in 95. So it's sort of like the international awareness is occurring now with respect to data mining as an emerging discipline. Okay. And then around 2010, now this wasn't so long ago, most people in this class were alive and most have some memories now. So in the 2010s, cloud computing came out, and that meant basically that everything's moved from local servers and local data being stored locally to data being stored in these giant data warehouse cloud places. I mean, the cloud isn't like in the sky. The cloud is like there's like big data warehouse buildings all over the place that house data. That's like where the cloud actually is. Um, I think they're pretty like high security kind of places. I've never been to one, but I'd like to visit. Um, so in 2010, now all of a sudden you start having a giant rise in machine learning and starting AI stuff starts. Social media also is a huge thing, Facebook and all that stuff. All of a sudden, there's a lot of stuff coming out that people want to start analyzing. Facebook got themselves in trouble, I think, a little for some of their data collection type things. But all of a sudden, the 2010s become this decade of the explosion of the use of data. And then in 2011, there was a IBM Watson, again, IBM, the same people that did that initial data mining software and did SPSS. IBM was a big tech company. They still are. There's a lot of other companies now, but when IBM started, like there weren't like a lot of other tech companies, if that makes any sense. So they had a computer win Jeopardy, and that showed the power of machine learning and natural language processing. And then in 2012, also Google released TensorFlow. I didn't actually realize that was Google's product, which is an open source software library for machine learning. And it's apparently one of the most widely used tools in the field. I did not know that. Yeah. Again, so 2010s were, of course, a huge decade here. 2015, deep learning arises. That is not just like the sort of supervised and unsupervised learning we look at, but going into neural networks and more AI computery stuff. 2019, the release of these language models for natural language processing, which means something like computer languages, like you have computer words, but they only have like one meaning, whereas natural language, you have words like, I don't know, no, because the word no can have different context. So you have like this sort of semantic word meaning. I'm not a linguistics person by any means, but this gives us not just the ability of computers to understand like basic computer words, but also the ability to understand like the context and meaning of language. And then all of a sudden you can start having like ChatGPT and AI stuff. And so this is 2019 and it's now 2023. So that's basically what's happened in the last couple years. Okay. Cloud computing makes it easier for businesses to access and analyze large data sets because you no longer have them in your own in your own building. They're like all over the planet and you can access them easily by the internet, which is perfect. Okay. Currently, the 2020s rather, data mining is evolving and expanding. If you're good at data analytics, you will be employed. And new techniques are always coming out, as we saw with ChatGPT earlier this year and other things. Data mining is sort of related to AI, but data mining is a subject in of itself. The techniques we learn in data mining do become the basics for artificial intelligence. There's more to artificial intelligence, though, including like natural language processing and computer stuff that I do not get into in this course because that is sort of, we really should develop some AI courses as well in the computer department. The 2020s privacy concerns and ethics. Now, this, if you took 101, I did that last module where I talked a lot about the sort of issues that I started seeing, and you should start seeing too. There's going to be a lot of issues with data and data ethics and privacy issues that are just coming out. So that's another big thing going on in the 2020s. Okay. So that was just sort of a tour of the sort of background of data mining. Okay. Next, let's look at different kinds of data. Now, data can be numeric, which is what we sort of think of from an intro stats class, because numeric data you can analyze with your basic statistics and stuff like that. One of my latest sort of arguments is that data analytics is actually quite different from math and statistics, because a lot of the stuff that data mining works with is no longer just straight numeric data. Binary data is your old kind of computer data. Ultimately, computers all write in binary code. Nothing, everything goes down to level zeros and ones and little switches going off and on. And that's what binary data is. Text data is something that I'm getting more and more into. This is your unstructured data, but this is still all data. And things like, when social media starts coming out more and more on the internet, then we have this explosion of data that, all of your Facebook posts and stuff like that are data that can be mined. And so we have this whole, interest in analyzing text information, which before, you couldn't do a lot of this until recently without the computational power and stuff. But now you can actually analyze text data, which is called unstructured data because it's not in a data table. But there's a lot of opportunity in unstructured data. I'd like to actually create an unstructured data class too, but I have too many projects. That would be really cool. I think that will come, but probably not for a little while. Categorical data you also learn about in basic stats. This is your sort of, it's verbal data, but it's like short stuff like colors and gender, species, not like your long text data kind of stuff. This is longer narrative data, and then this is like verbal data, but it's shorter. Time series is data collected over time. This will be covered a little bit in the applied analytics course, which is that when you collect data over time, it has specific patterns and analysis that you want to do on it. Time series data is very, very important because a lot of data, sales data and stuff, a lot of it's collected over time. And time data tends to have, it's a little bit different than, quote, regular data because it is sort of correlated. Like if you're collecting weather data, the weather from yesterday, it's all one season. So, from day to day, the weather's not completely independent of the previous day. So time series data is a little bit different when you analyze it. Spatial data is a big thing. UNH used to be big in this. I think they still are. And like sort of mapping, like the Earth. I don't know if the entire Earth's been mapped yet. It probably has by GPS coordinates. And so this is data as well. But, none of this is like numeric data. Only, binary data is not really numeric data in the same sense. Text data is not. Categorical data is not. Time series data is, but it's special because it's over time. Spatial data. And then image data as well is something that would be considered unstructured data. And I can actually do for this class, I might change a few things. There's like, you can actually do something like feed a computer pictures of cats and dogs, and then train the computer to distinguish between a cat and a dog. And that's analyzing and working with image data. There's no like number data directly involved there. So image data, of course, is data from images and visual stuff. And audio data is sort of a similar thing. I don't know much of anything about audio data, but also like this is not numeric data, but this is still data representing sound and speech. And you can, of course, analyze just about anything. Movie data as well, videos and movies. Those are sort of a combination of image data and sound data. And so that is the basics of what data mining is. I'm going to actually take a break here and go on to another video because this will get very long. Actually, no, maybe I'm not. No, let me think about this. Sorry. That's a different module. I'm on slide 41, and I have up until... Oh, yeah, I do need to take a break. I'm trying not to make videos too long because they just become... 20 minutes is a good cap. So this is the first part. I'm going to do a second part as well.